to help you analyze complex circuits. This week we'll add to your arsenal of techniques by looking at superposition and Thevenin and Norton. So superposition is a nice way that will help you simplify circuit analysis. It's a powerful general result. And then Thevenin and Norton theorems extend the idea of equivalent resistance to circuits that also have voltage sources and current sources. So it's like the equivalent of saying, here's a general circuit, find the equivalent resistance, but now there are going to be voltage sources and current sources dependent and independent there. How can you reduce that sort of circuit? Can you reduce it just to a single resistor? Probably not, but it turns out you can reduce it to just a single resistor and a single voltage source. And that's called Thevenin's theorem. So that'll be next lecture. But today, lecture 1 up there is superposition. Start off with a Meltz question. A current source of 0 amps and a voltage source of 0 volts are what, respectively? So is if I say a current source of 0 amps, is that an open or short circuit? If I've got a voltage source of 0 volts, is it an open or short circuit? So just to get us started this morning. I equals 0 and V equals 0. The equations of what? Is that good enough? All right. So that's interesting. So we've got 60 responses, but it's only 40 have the correct. So I'm going to lock it. Is that all right? It's not a touch screen. So if you can see, it's probably a bit hard to see that. I better dim the lighting. A current source of 0 amps is an open circuit. 0 amp current source means I equals 0 in that branch of the circuit, no matter what. I equals 0. Well, that's an open circuit. No current flowing through it. On the other hand, a voltage source of 0 volts says V equals 0. V equals 0, that's the equation of a short circuit. There's no voltage across that element no matter what. Well, that's a short circuit. So C is correct. Current source of 0 amps is an open circuit. A voltage source of 0 amps is a short circuit. Some people had it the other way around, but does that make sense? If not, because what we're going to do with superposition is we're going to zero sources. We're going to get rid of a current source or get rid of a voltage source, and this tells us how to do it. If you want to get rid of a current source, it's equivalent to saying I equals 0, so you make it an open circuit. If you want to get rid of a voltage source, it's equivalent to setting V to 0, so it's a short circuit. So we'll be doing this in our principle of superposition. So in the last lecture, we found this current I0 using loop analysis. We can actually make use of the principle of superposition to make analysis simpler. Okay. So if I said find I0, there are many ways you could do it. You could use loop analysis, you could use nodal analysis. They'd be the two main techniques we'd have at the moment. Superposition will give you an alternative way. What does superposition tell us? It basically says you can look at each source one at a time. You can look at all the independent sources in the circuit and analyse them one at a time with all the other ones set to 0. That's what superposition says. In any linear circuit, and all the circuits we've looked at in lectures and tutorials are linear, containing multiple independent sources, so a voltage source and a current source, 2 voltage sources, 3 current sources, whatever it may be. The voltage or current at any point in the network may be calculated as the algebraic sum of the individual contributions of each source acting alone. So if I go back here, I could first look at that 6-volt source up the top, leave that in, but get rid of that 4 milliamp current source. To get rid of a current source, I make it an open circuit. And I could get rid of the 2 milliamp current source, I make it an open circuit. That circuit I'm left with just a single source and resistors might be easy for you to analyse, or easier. So you analyse that, you get a result for I0. Then you look at just this alone. The others set to 0. Then you look at just that alone. You set the result to 0. You had a value of I0 from all of them. Now when they're all in the circuit, the overall result will be the sum of the individual currents you found. That's the principle of superposition. Because of linearity, this is why it works. You can look at each one acting alone and then add up the results at the end. That's also a superposition. Don't try it at home. As I said, when determining each source's contribution, use 0 other voltage sources with a short circuit and use 0 other current sources with an open circuit. That shouldn't be a mystery. I equals 0, open circuit. V equals 0, short circuit. So here's a simple example to start with. A question might say, use superposition to find V0. Now, you don't have to use superposition. Simple nodal analysis might do this for you very quickly, or loop analysis. But let's see what superposition does to allow us to find V0. We start by getting rid of one of the sources. Let's get rid of the current source. And to get rid of it, I replace it with an open circuit. So it's gone now. The V0 that I'm finding here is not the final answer, so I'm just going to call it V01. The one I'm finding with just the 3-volt sourcing. You can see that as soon as I've got rid of that current source, I've got a single loop circuit. A single loop circuit with a voltage source and 3 resistors in series. So that's one that we can analyse without any fancy techniques. I don't know how you want to do it. You could just use voltage division, or you just find the current. It's a single loop circuit, equivalent resistance added up, 6 plus 2 plus 1 is 9 k ohms. So you can work out the current, so you can work out the voltage on the resistor. I'll use voltage divider. So voltage division will tell me that V01 will be the 6K divided by the total, 6K plus 3K times 3 volts. How much of that 3 volt source drops across the 6K resistor? Well, it's the 6K resistor divided by the total resistance, times the 3 volts, which is 2 volts. So if I had just that 3 volt source acting alone, I'd find 2 volts across that 6 ohm resistor. I've got to get rid of the voltage source now. I short circuit it. That's now my circuit to analyse. And I want you to do that one, please. On melts, if I can. Yep. Maybe not. Bear with me for 1 second. Woo! Anyway, you work on it. You don't need to see the answers yet. Oh, there we go. So you've got to basically find V0 if you just had the 2 milliamp current source acting alone. That circuit is also simple. It's just a 2-node circuit. But you know, the single loop circuit and the 2-node circuit were the ones that we saw were fairly easy to analyse. How are we going? Got it? No. Okay, so that's important because I could have given you this in lecture 3. Yeah? Or I've got no answer there? Have I got?
Yeah.
Okay. That's a current divider. Use any circuit analysis technique you want, but it's simple enough that you just have a current division. The 2 milliamps flowing up, it can choose 2 paths. It can go through the 6K resistor or the series combination of 2 plus 1, 6 or 3. So current division that we did back in week 2, or simple 2-node circuits. Once I'm analysing this isn't about superposition. Let's just analyse that circuit. Find the voltage. I'll have a look at how you're going. Bear with me. Okay. Too small in preview mode. So nearly everybody has done that. So I'll lock it, show you the results. So a lot of people think 4 volts. 60 out of 70 people think 4 volts. So let's just check. Yeah, so as I said, you've got 2 milliamps coming up here, can split that way or that way. That's a current divider. So if I wanted to know that current there, it will be, well, the 2 milliamps times, how's it going to split? I get the other resistance is 3K 2 plus 1 on the total, 3K plus 6K, which equals 2/3 of a milliamp. Therefore, what's V02? I'll call it now. V02, just the 2 milliamp source acting alone. Well, it's 2/3 of a milliamp times 6 k ohms, which is 4 volts. All right. What's the total V0? Well, it was V01 plus V02 by superposition. Analyse one circuit, analyse the next, add up the results. What was the last one? 2. 2 volts for V01 and 4 volts, so I get 6 volts overall. You could redo it using Nodal or loop or some other thing with both sources in there right from the start, and you'll also, hopefully, get 6 volts. Now, any questions about the analysis of to find V02 there? That was, of course, nothing new. If you have a problem working out that voltage, then you might have a problem. And I'm very happy to chat to you afterwards if there's an issue there. Because as I said, that bit's not superposition. That bit's 2-node circuit analysis, current division, stuff we did in week 2. Are there any? Do you want to? If you've got a question, I've got a coffee voucher for you. No? You're all right now? Okay. Yep. What's a nonlinear circuit? Okay, so you've have you used a nonlinear element in any aspect of this course? Diode. You've used a diode. A diode has a characteristic that is very strange. It only operates in one direction. Think of a resistor, linear. VI, put negative voltage on it, negative current, positive, whatever it may be. A diode has something that looks like that. Current will only flow in one direction, and it has sort of very little resistance when it is flowing. Its characteristic of a diode is typically some kind of exponential behaviour, in fact. So, good question. A diode would be your classic non-linear element. There you go. I'll give you this. Yet another superposition. Very comfortable. Keeps you dry. There you go. Here's another one. Again, a voltage source, a current source, and a few resistors. When we're down to one source, basically this notion of equivalent resistance probably comes into play. So again, you could attack that directly using nodal or loop, but let's try superposition, where we get rid of that. Analyse it just with the voltage source acting alone. And I have to find V01, the voltage on the 6K resistor. Can you see 2 resistors that are in series now that I've got rid of that current source? So I think I whispered at someone here. The 6 and the 2, this one and this one are in series. They've got the same current flowing through them because there's no current out here because this is an open circuit in this area. So indeed the 2 and the 6 are in series. I could combine that to an 8K. What is that 8K then in parallel with? The 4, which is in series with the 2. So you can now, I've only got one source. I could do this thing of just finding how do you want to analyse it? Find the equivalent resistance. Then I would know this current here, I. I could find that I as soon as I find the equivalent resistance from Ohm's law. Then I could use current division to find I1, and then I could find V0. So that's one approach. You might have your own way of attacking it, but I'm going to say the equivalent. Hey, can I'll say hello. Oh, the alarm to come to lecture? Yeah. Oh, jeez. I wonder you're always late. What's the equivalent resistance? We said the 6 plus 2, 6K plus 2K, is then in parallel with the 4 and in series with the 2. So if you add all that up, you get 4 and 2/3 k ohms. All right, so that would be the equivalent resistance, meaning that what I really have, I could rewrite this as plus minus 6 volts, R equivalent, where that's I, and that's my I here. So I can work out I straight away as 6 volts divided by R equivalent, which equals 6 on 4 and 2/3 milliamps. That's a little bit messy. That equals 9 on 7 milliamps, I think. 3 4s are 12, 14 on 3, 18 on 14, which is 9 on 7 milliamps. I've just found that that is I, and I want to know I1, because if I find that current, I can find the voltage V0. Well, I1 will equal I times what? There's a current division. I can flow through that 4K resistor or through the 8Ks, the 6 and 2 in series. So I can go through 4K or 8K. So the current that flows through the 8K down through here is the other resistance, right? So it's 4K on 4K plus 8K, the total. I've already found I was 9 on 7, so I can plug all that in, and I should get 3 on 7 milliamps flowing down through that 6K resistor. Therefore, V01 equals 6K times I1, which I've just found above, is 18 on 7 volts. So the superposition part was getting rid of the current source, analysing that circuit alone, and then it's what circuit analysis technique do you wish to use? Could still use loop analysis there if you got stuck, or nodal, but that doesn't actually make it much simpler than just using nodal or loop on the initial circuit. Here we take advantage, when there's only one source, we can find the equivalent resistance seen by that voltage source. That allowed us to find I, current division to find I1, and so on. Those basic circuit analysis techniques from week 2. Any questions about it, about that? What we've done? No? No? All right, have a bit of a musical interlude. We saw the drone orchestra last week. He's a fantastic flautist, robotic flautist. The eyes obviously add a lot of value to the flute playing. And the hat, all important. So there you go, something to try at home. As I said, my guitar playing robot final year project doesn't look quite that good. Current source alone, there's another circuit to analyse. How do you want to attack it? We've got to find V0. V0 is actually the voltage on the current source. If you have a look at it, that V0 there. So if I could find the equivalent resistance seen by that current source, all I have to do is multiply 2 milliamps times the equivalent resistance. See that? Because the voltage is actually the voltage on this current source here. How would you break that down? What's the equivalent resistance seen at these terminals? Seen by the current source. What's in series, what's in parallel? Yep. This one and this one, they're in parallel. They've got the same voltage across them. That's the definition of parallel. So I could certainly have, if I'm interested in finding the R equivalent, I've got 2 in parallel with 4 to start me off. What's that then in series with? This 2. So you've got this coming through here. This one and this one I combine, put those in parallel. So I can add 2, and then what? That whole thing is in parallel with 6. So that's the equivalent resistance seen by the terminals, the 2 milliamp current source. So that's 2 in parallel with 4 is 8 on 6. I'll let you think about it, reduce it down, but it should come out at 15 on 7 k ohms. They're not nice numbers, but 15 on 7 k ohms as the equivalent resistance. What I've reduced this to now is this circuit, 2 milliamps, R equivalent, and the voltage that I wanted that whole time was here, plus, minus, V0. So to get V0, I multiply the current 2 milliamps times the equivalent resistance, and I'm done. So therefore, V0, and I'm going to call this V02, because it's not the final answer yet, V02 equals 2 milliamps times R equivalent, which equals 30 on 7 volts. So just that current source acting alone, using the equivalent resistance concept, I don't really need to get into nodal and loop analysis. When just that current source is there, I can write V02 in that way. The final result, V0 was V01 plus V02, which was 18 on 7 plus 30 on 7, which is 48 on 7 volts. So that's the basic principle. Each one acting alone leads to a simpler circuit to analyse, and then you just add up the results at the end. Okay? Has anybody got, does anyone work and have a shared kitchen where they work? No? No one? You do? Do you have your cup there? Your own cup? Does it piss you off when other people use your cup? Usually hide it. Well, I've got another idea for you, my friend. Here's another great invention. It's called the lock-up. This has got a plug in it, this cup. Can you see this beautiful plug here? This would normally be attached to your keyring. You can use your cup, that's fine. When you've finished using it, you take the plug out because it's on your keyring and walk away. You can leave it sitting there on the shelf, that's fine. Person tries to use it, pours the hot water in, comes straight out and scalds them. That's the last time they're going to use your cup. This is genius, absolute genius. There it is on the keyring. You see it there like that? This is the sort of thing that we want you to do. Come up with great inventions like this. So I've got one for you in my office. You can come and get it afterwards, all right? Yeah, excellent. The lock-up, I can order them for you if you are interested. If you leave the keys on the cup, then someone can steal your cup and your car. You wouldn't do that. You mean?
What problems does it solve?
All right, because you'd forget to take it.
Well, there are dumb people in the world.
Oh no, forgetful people. That's different. Just forgetful. All right. Here's one with 4 sources: 3 independent and 1 dependent. So your next melts question is to find V0 from the 4-volt source acting alone. Find V0, if we can isolate where V0 is, this thing here. So this is what we want to find from the 4-volt source, this one here, acting alone. So start having a think about that. It looks complicated, but as soon as you start applying the principle of superposition, you get rid of sources, some of the sources. It's a reasonably simple circuit. Get your brains working and see if you can crack it. Sorry? Did you have a question? Yeah, so when there are 3 or 4, so the idea of superposition is one source acting alone. You get rid of all the others. I'll just have to kill it for 1 second, if that's all right. So I can... What is V0 if the 4-volt source acts alone? It's open. Oh, there we go. Any thoughts? You done? What did you do with the dependent source? Oh, dependent. Yeah. That's the... You can only do it for independent sources. That was a track. How's it going? Oh, no tutorials this week, that's true. Can you do that? Have you done that? Haven't done it? Oh, have a crack. Do you know how to start? So 44 people say 1 volt. Who got one? Who said 1 volt? Why did you say 1 volt? How did you do it?
If you like take away all the other sources except 4 volts,
Yep.
like a series of 4 1 kilo ohm resistors, and so there's total 12 ohms, and so it's 1 volt drop across.
Okay. It's good. It's right and it's wrong. That's the circuit you should have analysed. Okay, you can't take out dependent sources. You can only do it for independent sources. So you can zero the 2 independent current sources, but in fact for superposition in this circuit, every time you did it, you would leave in the dependent source. Think of a dependent source more like a resistor. It's not providing stimulation into the circuit. You need an independent source to do that. If you got rid of all the sources with just that dependent source in there, it's not going to do much. What's providing the input stimulus? It's the independent current and voltage sources. So that's the first trap or trick. Only the independent sources can be zeroed. So that would be the circuit to analyse. Now, as it turns out, you could analyse that circuit and you will see that V0 is 1 volt. Use loop analysis. You could use, I think loop analysis is quite good there. I'll just sketch the idea for you. You could say there's a loop, current I1, there's a loop, current I2, but when you go to do Kirchhoff's voltage law around that loop, what you'll find is that I2 equals 0. You actually get I2 equals 0, so the circuit that then results is the one you would have got if you'd got rid of this in the first place. But hang on a sec, anyway, if you did that, wouldn't this have been a short circuit? But getting rid of a voltage source is a short circuit. So if you had got rid of it, that should have been shorted, meaning you would have bypassed these two, so the answer should have been, the answer still would have been 1 volt, wouldn't it? No, the answer would have been 0 volts, because you've shorted it. So you kind of got the right answer by the wrong way. Doubly wrong. So the point is, leave it in, leave the dependent source in. It's then, is it harder, a bit simpler to analyse. I've got 2 loops if I do loop analysis, but I'll end up getting that I2 equals 0, so that I effectively have this single loop, 1, 1, 1, 1, which has got the same current through it because I found out that the mesh current I2 was 0. So it's 4 volts through 4 k ohms in series. I get 1 milliamp flowing through it, and so V0 would be 1 volt. That was the correct answer. But to get it, you've got to leave the dependent sources in. Is that okay? So that's the lesson. 3 independent sources, so you would analyse 3 circuits. The dependent source is left in every time. So you'd have an independent and a dependent source in each one of your circuits that you had to analyse. Can I get 2 students, volunteers, please? Coffee vouchers. You pushing in? You won't have to do much. It's very easy. The easiest work you'll do all day. 2 volunteers? Come on. How many coffee vouchers do you need to do it? Come on. Come down. Excellent. And given you were pushing him, you can come too. All right. What your task this morning is to somehow, I want you to demonstrate linear. What? Linear. What's a linear circuit? Demonstrate linear. You could lie on the floor and something like that. No? Demonstrate linear for us. Just lie down on the floor. Why don't you just lie in a straight line? There you go. Line yourselves up. Linear.
There you go, and you lined out a straight line there like that. Look at that. Heads down, I think. Otherwise, you might. And feet together. Feet together. Thank you. Look at that, linear. There's something that's linear. Now I want non-linear. Feet together again. Look at that. There's more like the diode characteristic that they've just made now, if you can actually see them. They've demonstrated linear and non-linear. I wouldn't say superbly, but reasonably well. Thank you very much for that. And you each get a coffee voucher. You will now never forget linear and non-linear. What does it really mean? Do you think straight lines? For us, here's what it means in a circuit. I took this one we've already analysed today, but I made the sources Vx and Ix instead of specific values. If I said find V0, it will be something exactly of this form. Alpha Vx plus beta Ix for some values of alpha and beta that you could determine. But if you did the analysis, you left it in terms of Vx and Ix, it would be a linear function of Vx and Ix. That's what linearity means. Any voltage or any current in this circuit will be of the form alpha Vx plus beta Ix, but for different values of alpha and beta. That's what linear means. Anything is a linear function of the input voltages and currents. Okay, that's really what linearity means. And you can see now why superposition works for these linear circuits, because what it corresponds to doing is I can get the output if I just have Vx acting and I set Ix at 0, and then I could do the other way and then just add up the results at the end. That's why superposition works. Okay. It must be of the form alpha Vx plus beta Ix. So if that is the case, we found earlier that for this particular circuit with those values that V0 was 6 volts. We found by superposition. What now happens if the current source is 4 milliamps and the voltage source is 6 volts? If I double both of those values, what's going to happen? So that would be this one here. It's answered. So if I double the current source and I double the voltage source, what happens to voltage V0? Or what happens, in fact, to any voltage or current in the circuit? Everybody thinks 12 volts. Some people think you do it, I'm tired. And now everybody thinks 12 volts. So from that, the fact that V0 was alpha Vx plus beta Ix, if I doubled Vx and I doubled Ix at the same time, then I'm going to double V0. I'm going to double any voltage or current. Will just double. If I double just one of them, if I multiplied, Vx by 2 and didn't double Ix, then I couldn't say that. I could if just when I was looking at just Vx acting alone. But when they're both there and I double both of them, then the output must double. So that's a powerful result. That's why superposition works. And you'll see in the tutorial, which is not this week, no tutorials this week. work harder on your lab test preparations. But you'll see there are some questions that if I've solved it for this particular value, what's now going to be the case for this particular value or something. It's trying to exploit this linearity. So keep in mind, any voltage or current in a circuit will be a linear combination of all of the independent voltage and current sources. That's linearity, that's superposition, and thanks for coming in this morning. I'll see you on Wednesday.